And welcome back. Today's email comes from the viewer Michael, and he says the following. Dear Lab Coat Math, I just came across your channel and wanted to know if you can help on geometry proofs. I was warned that this class is tough and the proofs are just too much. The problem is attached. Thanks. Very good, Michael. No doubt that geometry is one of the challenging math subjects for many students because of all the things that need to go on. You have these large proofs, you have so many rules to memorize, and there really is no direction if they just give it to you blank like this. But this, along with any other questions, can be sent directly to the email labcoatmath@gmail.com, and we should be able to find a time to do these types of problems through video. So let's get through this one step at a time, as geometry is just another way of logically going down a path of steps to prove mathematically what we want in the end. So let's take a look here. We have, looks like, a lot of triangles here, but there really are only two big ones for us to start with, because starting here that they gave us that the line PQ is perpendicular to QR. So as you see here, we have that nice 90-degree angle because it is a perpendicular line, along with PS being perpendicular to SR down there as well. And one last thing is that they said PQ is congruent to PS. So at least for us, we can go and put those tick marks there to show that that is the case. Now, as to the best way of starting any sort of proof is listing out all of the givens, so exactly what they gave us to start with, as those three statements of PQ being perpendicular to QR, PS being perpendicular to SR, and PQ being congruent to PS. Now, again, the proof though, what we need to end at with our last step is showing that O, that point right there in the middle, is going to be the midpoint of QS. So QS is over there. We need to show that QS has been indeed cut in half by point O. So let's go ahead and see what we can do here. It looks like we are already very close to figuring something out here, is because we have ourselves already one of the things going on here, the fact that we have a 90-degree angle, so we have two right triangles stacked on each other, acting as if line QS wasn't there to begin with, which means that if we have, looks like one set of line segments, PQ and PS already being congruent with the right triangle, we only need to show that the hypotenuse, so again, that angle that's opposite to the right angle, or the longest side of that right triangle, if we show that PR is congruent for both of these, well, that makes the whole large triangle sections congruent to each other. That's pretty nice because that might help us determine some other nice little sections for ourselves that would also match. So why don't we do that? And would you look at that, PR is being shared by both of those triangles. So we can begin our first line saying PR is congruent to PR. Seems very self-explanatory, but mathematically we do need to show that on the second step, because this line PR is shared by both right triangles, and it is the same exact hypotenuse across both of those triangles. So with that in mind, the reason of course for that is that that is known as the reflexive property. And this property, of course, is just that anything congruent to itself is simply itself. So that's pretty nice that we can show that we have that segment there. But now we can use one of these special rules for triangles to show that PQR, so this top triangle, is going to be congruent to PSR, that bottom triangle. And what rule would that be? Well, first, let's list that out as our next statement, that we want these two triangles, PSR, is going to be congruent to the triangle PQR. And so each of those large triangles are going to be congruent to each other, in which, because of that, that's going to be with the reason of something known as the HL postulate. Okay, and this is for triangles. Okay, HL being hypotenuse leg. So again, thanks to Pythagorean theorem, is that if two right triangles share the same hypotenuse and share a length that are both congruent to each other, well, Pythagorean theorem will dictate that the third leg must be congruent to each other, which, by taking the next step of realizing that if all three sides of a triangle are congruent to each other, those whole triangles are congruent. Makes life, that is, a lot easier for triangles, given that we can just use HL, knowing that the hypotenuse of both triangles and one leg of both triangles are congruent. That's enough for us. Okay, now to really show for it though, as to why we went that length to show that those two big triangles are congruent to each other, the idea being that we need to find ways to make these smaller triangles. Let's actually switch colors here just to show it a little bit easier. But we want to show that these smaller triangles, if you can see the direction that we're going here, so we have PQO and PSO, right? These two triangles actually share that whole side of QS that is our main target. Of course, the bigger triangles, PQR, PSR, have nothing to do with that QS line that we're looking for. So we need to find ways to break it down so that we can show that these two now are then congruent to each other. Because of course, if, now again, this is yellow because this is the if moment, if we can show that these two segments are going to be congruent to each other, well, that is our goal right there. That O is the midpoint of QS. Midpoint, of course, being that point which cuts the entire segment directly in half. So if we can get there, we can then conclude with the proof and our job is done. Of course, we still have all this middle section to go through to really prove that those two smaller triangles are congruent. Right now, all we have is the bigger triangles of PQR and PSR being congruent. So what can be helpful? Well, what do you notice is that when you look at this a bit closer here, is that we have these two angles of QPO and SPO in that order. Those are the same corresponding angles of those two bigger triangles, and thankfully they are actually shared by these smaller triangles too. I think that's a nice connection there. And would you look at that, we have ourselves another step for ourselves, is that we can show, let's go back to blue now because that's what I started with here. There we have angle now, again the corresponding angle is QPO being congruent to the angle of SPO. Again, those two must be congruent because we have the larger triangle PQR and PSR, and again those are the corresponding parts of the triangle, again because we already proved that these two triangles that were bigger were congruent to each other. And of course, we can just label that as CPCTC. The great big abbreviation for those geometry students knowing how to do triangles is that the corresponding parts of congruent triangles are congruent. A nice, great acronym, but at least for us is reason enough to show that these two angles that are corresponding to each other are then congruent. Oh dear, we are right there at the cusp of greatness. Would you look at that? We still show that PQ and PS are congruent to each other, which is also shared by those smaller triangles. But would you look at that? PO is shared between those two smaller triangles as well. And looks like we have a side, angle, and side. Oh, that is exactly the formula that we need to make those smaller triangles congruent. So we just need to go and prove that PO is going to be congruent to itself. A very nice line for ourselves because it's very easy and convenient. That with PO being congruent to itself, that is going to be done once again by the reflexive property. Okay, and why did we care about doing that? Well, if you can see it by now, we have almost everything we need to put together to get those triangles congruent. We have one side, PS and PQ, that is shared by those smaller triangles. We have the two angles that we just got congruent, and then we have PO being congruent to itself. A side, angle, and a side. Oh dear, that is exactly what we need to do in terms of another rule for triangles, is that if we did the side, angle, side postulate, that will then prove that two triangles which share a side, angle, and a side incongruency, the whole triangle must be congruent. And now we've gotten it, that the smaller triangles, QPO and SPO, must be congruent to each other. So not just the angle, but the whole triangle, QPO, will be congruent to triangle SPO. And that was done with the side, angle, side postulate. Now we are right at the doorstep, because given that these two triangles are congruent to each other, we then can show that QO and SO are going to be congruent to each other, as those are corresponding parts to congruent triangles. And that is going to be step number 7, showing that the QO is congruent to SO, and that will be done with the good old CP-CTC once more, because we've already proven that those triangles are congruent. And would you look at that, we had everything we need to finally get to our last step, the 8th step of showing that O is the midpoint of the entire segment QS. Okay? And would you look at that? Of course, we've shown that the two segments from QO to OS are both congruent to each other. That is simply going to be the mathematical definition of a midpoint. And would you look at that? We have finished this entire proof in 8 steps. Oh dear, that's so many. Well, sometimes that is what is needed to get from our beginning part all the way to the ending part for this entire line of work. I personally do like proofs because it lets you go through one individual step at a time without any dispute as to what you're trying to reach at the end of that proof. In geometry, I think that's one of the best parts about it. Many students will complain that is the hardest part about it, but nonetheless, it is good practice for a lot of students just to be able to have blank proofs so that they can reach back in their minds to go through all the rules that are gone over, most likely in class, that need to be memorized for students to then follow up with finishing off this kind of work. So, hope that helps, Michael, in terms of what you are looking for, but as well for everyone else that's watching, that all different types of questions related to math are welcome to that email, labcodemath@gmail.com. And this series will continue so long as we get more emails coming in from students like you. So, thank you all for watching, and we'll be back again next time with some more questions.